Hi, I'm Leif, and in this video we're just going to run through how you can hack the CWL framework and add your own metric. So the Cool framework basically has a few classes that we need to interact with. And so the first one of these is just a ranking class, which is essentially a construct that represents the costs and the gains. So this ranking object just allows you to define a few things, the topic ID, so that's the name of what's going to be in the output, and then a vector of gains and a vector of costs, and you can configure a number of other options like specifying how, whether you want to normalize the gain and costs with respect to certain numbers. And so it's just going to be a container class that we will use and we'll pass these rankings to our cool ruler, and then the cool ruler object will then will then measure that ranking. And so when we construct our cool ruler, you can see here it potentially takes in a metrics file, which you can then use reflection to read in all the different metrics. But if that's not specified, then the standard list of metrics will be, this standard set of metrics will be instantiated and reported if that metrics file is not provided. Right, and so essentially you'll ask the cool ruler to measure a particular ranking that you pass through, and then it will just go through, and for each of the metrics in your list, it will then pass that ranking to that metrics measure function, and then go through and actually perform the measurement. Right, and so the cool ruler handles the reporting and output from all of those metrics that you've identified. Right, and so given those two classes, then within measures we have a base class called cool_eval_metrics, and this is used for creating new metrics. And essentially, in order to define a new metric, we just have to subclass the C vector, so the continuation function, right? Because once we define that, then we can work out the W and the L, and then the machinery just works to compute all the values. Alternatively, we might not know what the C function is, but we know what the weights are, and if so, we can define the weight vector and then convert the weights to continuation probabilities. And of course, we should also define the name of our metric, right? So, for example, if we're defining something like DCG, we'll specify the name of it. And then we have to specify the C vector, right, the continuation function, right? And so recall that the C value is just the log of the base of the ith item plus 1 divided by the log of the base of ith item plus 2. And so we just encode that within a vector. So here we just have a list. And then once we make those lists, we just pass back a NumPy array. And now that's happened, then that basically defines our metric, because the base class defines all the other properties. So just looking in the toolkit here, so you know the CWL metric is going to output all these different values for us. And once we define our vector, then the L and the W vector will automatically be computed given the C value, right? And so for discounted cumulative gain, you can see that we've implemented the value here. Also defined that's going to take a K parameter because that's how it's parameterized. And we've also added in the bibtech for it. So, you know, if you're making your own metric and you've got to publish, then you can also put that in here. And so it spits it out when people do the -bib. But that's essentially, you know, it. So once you work out the math for the C vector, you know, it's only a couple of lines of code to add in your own measure. So similarly with RBP, it's even simpler because it's just a C vector basically of theta values. So C for RBP is always theta, and so we're just passing that in, and so you can see that's pretty simple. Now sometimes we don't know what the C value is, right? And so so the example of this is something like the U measure, where in order to work out the C value, we actually compute the W vector first. So over here, from their formula in their paper, we can work out what the weights are at each I, and then we create that W vector, and then return that NumPy vector here. And now that we have that, we can then utilize that within the C vector in order to compute the C's, because remember that C is just the weight of the result of I plus 1 divided by the weight at I, right? And so then we can reverse it around from there. So that just concludes a quick overview of how to hack the Cool-Eval framework to make your own measure. Thank you for listening, and remember to like, comment, and subscribe to the video.